Okay, so um, this was very disappointing to me that I didn't make it to Oshkosh. It was going to be my 45th year, and I screwed it up and didn't get there. Got about halfway. Um, and what I'm going to tell you in this presentation is, when I got home, I decided to tear the engine down and see if I could discover what was wrong. And I'm going to walk you through everything I looked at and so forth. And then I'm going to speculate on what I think the problem was, but we don't know for sure. It's kind of confusing. Anyway, this. What's your airplane? Oh, it's an RV-12, and I'll show you the pictures of the engine in just a minute. It's a highly modified RV-12. Like, I have fuel in the wings and a bunch of other stuff like that. Okay, so this raises a big question. See how big it is? What went wrong? I didn't know. First, let's take a look at the engine. It's really a beautiful engine. It looks like a small Continental if you were designing it today. The camshaft is underneath. There's the oil pump right there. The camshaft's underneath, so it's always bathed in oil. It uses modern CNC technology, modern metallurgy, all the good stuff of a modern engine. The guys that founded this company, UL Power, they make Formula One engines. So this is a hobby for them. So this is a breakaway of the engine. Some of you have seen this before. You see the slipper pistons, crankshaft here. This is a 5 main bearing journal crank, not 3 bearings, 5. So that stabilizes the crank between the cylinders when they fire, and it makes it run smoother. It's very, very nice. It's direct drive, no gearbox. It's air cooled. That means no radiator, no water pump, all the things that will take you down if you're doing an automotive conversion, which I did. I had 2 automotive conversions on this airplane, and both of them tried to kill me a total of 7 times over a period of about 4 years. That's 7 emergency landings. And so I finally did this. A couple other things. It's a, like I say, modern engine. It's really built for reliability and accessibility. Um, for example, there's the alternator is a 50 amp 3-phase dynamo back there. It's bolted directly to the crankshaft, so there's no belts, no pulleys, none of that stuff. And there's a cam underneath. That's the oil pump is sitting right there attached to it. So it's a very nice engine, and they did some nice things too. First of all, that's a 6th bearing. That's the thrust bearing up front. It's a roller bearing. It costs $100 just for that bearing. I don't know what ceramic balls. I don't know what it is, but it's much more hefty than you would see on a Lycoming. And look where they put the oil filter, right up front. So you put a bucket on the floor, take the oil filter off. It doesn't get all over your firewall and all over the belly of the airplane. And so it's wonderful. So I love it. I mean, I've got about 200 hours on it, and other than cylinder number 2 right here, I've not had any problems with it. So cylinder number 2 basically never broke in. Over the years, about 180 hours, it developed lower and lower and lower compression. The increasing oil burn, their oil burn was about a quart in 6 to 8 hours, whereas normally on this engine it would be a quart in 20 hours. So I knew it was something wrong, and when you bore scoped it, sure enough, there was a trail of oil in there, and it just, all the other cylinders were perfect. So there's something wrong with this cylinder. It was also glazed. So just before Oshkosh, about a week before Oshkosh, I decided to tear it down and remove that cylinder and do a top overhaul on that cylinder. So I did that. Basically all new rings, gaskets, seals. I lapped the valves, and I took it over to B&G and had Brad do a crosshatch hone to remove the glazing and put the crosshatch hone back in there. I did not replace the piston or the cylinder, and that turns out to be a mistake. So after about only 3 hours of hard running, breaking it in properly, I was running like at 80% power for 3 hours in the air. Can't do that on the ground. I left for Oshkosh on Friday before the show. And I noticed during this break-in, I wasn't measuring the oil, but I expected in the first hour, I'd probably have to put a half a quart in there. In the second hour, it should be less and so forth. But I wasn't measuring it, but I noticed it was kind of burning too much oil. And it didn't look like it was, once again, not breaking in. So I decided on the trip to Oshkosh, the original plan was we were going to go stop in Des Moines overnight so we could get there, beat the crowd on Sunday morning. But concerned about the oil consumption, I didn't know how bad it was, and I didn't know it was going to get worse. So I broke it up into 1 hour segments. First one was to Fort Worth, where my son lives and where he keeps his RV4. That's Borland Field, right there, just north of Pecan Plantation. And then we did that, stopped in McAllister, checked the oil, had breakfast in Bentonville. It's a great place to have breakfast. And got to Kansas City. But at every stop, I put a full quart of oil. So I'm burning a quart an hour. And when I did the Armstrong compression test, I can tell one of the cylinders is really soft. I don't know which one, but I knew I did. It was the one that I had just repaired. So I figured. Are you making full power? Just curious, like up in the air. Well, the engine ran smooth and quiet, and the airspeed was, there was some horsepower missing. Like on takeoff, I was down about 50 RPM, and which would be consistent with oil contamination in one cylinder. Also, if you look at the CHTs and EGTs, it's cylinder head temperature and exhaust gas temperature. This is what they normally look like. The CHTs run about 225 on the front two cylinders, that's the white bar, and about 250 on the back two cylinders, which you'd expect that because the front two, they get all the cold air coming in. The back two have got kind of warm air and maybe not as much of it. So that's what they normally look like. This is the EGTs. Look at that. They're just straight across, 1400 degrees. Now, on this trip, this is what it looked like. You can see, look at that EGT. It's down 100 degrees almost. Again, consistent with heavy oil contamination in that cylinder. So here we are in Kansas City. I'm thinking, we didn't make it to Des Moines. I'm thinking, the engine's running fine. It's not getting any worse. And I really don't want to miss Oshkosh. So I have a choice. Do I tuck my tail between my legs and go back home? Or do I fly another 500 miles away from my tools? No. So I turned around and came home. Now, I began to tear it down and going. I'm going to show you pictures of the steps I took where we're looking for something obvious. Okay. First thing, we got to remove the baffle shrouds. Okay. Well, on this engine, that whole assembly comes from the factory, CNC cut to fit around these tubes, to fit the cylinder, etc. It's held on with 2 screws right there, right there. It comes off in your hands. Thing of beauty. That'll take you half a day on a Lycoming if you hurry. So no problems there. Same thing, exhaust is good, easy to get off. No problems in here. It's the rocker arms and the valves. I didn't expect to see anything wrong there. But I had to remove the valves and the springs in order to get the cylinder head off. So I did the Lycoming rope trick. You've seen me talk about that before. That's where you stuff the cylinder full of rope so that when you're compressing the valves to get the springs off, the valves don't fall into the cylinder. It's called the Lycoming rope trick. There's actually a procedure from Lycoming to do that. So here are the tools that I use. There's special depressors where you can depress that big spring. It's a really hard spring, and remove the little keepers that maintain it. So you can see where the keepers attach here and they're in there. So when I depress that, I can remove the keepers, and then I can pull the springs off like that. No problems. Nothing. Everything's clean. By the way, now as I'm taking the rope out, I put a piece of plastic tubing on the stem of the valve to keep the valve from falling into the cylinder. Okay, that's all that is. So there it is. I pulled the head off. No problems other than the fact that it's kind of coked up dirty. And then I can remove the cylinder. 4 bolts, comes off real easy. Now, what I expected, the only thing I could think of is that, and I talked to the repair stations, they said, it sounds like you got your one or both of your compression rings upside down. And I thought, I don't think so. Not only was I very careful, but Brian was there helping me, putting the rings on and very carefully making sure we got them right. But I got to looking at this in the instruction manual, and I found something very interesting. The rings are beveled. There's a little bevel on them. And it's important to get that bevel in the right direction. Everybody know why rings are beveled like that? They're beveled like that because when the combustion gases in very high pressure, about 2,000 psi, gets exerted against the ring, that bevel causes the ring to act like a Belleville washer. It actually does this. It does that every cycle. And that is critical to how it interfaces with the cylinder wall. And it's very, very important. If you get it upside down, you're going to burn oil like crazy. So that's what I thought I was going to find. And the reason I thought I was going to find it is because of this page in the instruction manual. If you're just looking at the pictures, it says piston ring number 1, which would be the top ring. The bevel will be down. Piston ring number 2, which is the second ring, it would be up. But that's not what that says. Piston ring 1 is the middle groove, not the top groove, not the bottom groove. How insane is that? And I actually called the factory and told them, this is why you're having so many people put their rings in upside down, because they look at that picture and they put that one in the top and that one in the bottom. They're upside down, both of them. But that's not what I found.
Was this, how about the other cylinders, the other pistons?
How what?
How about the other, why would that be different than the other 3?
Oh, they're all the same.
Right, but when you install them, are they all consistent, all 4?
Yeah, they're all, everything. The other 3 cylinders are perfect. So that I eliminated that. Now I'm really puzzled. Again, no problems here. The only thing with the head was that it was heavily coked up, which was consistent with a lot of oil in that cylinder. Also, when you bore scoped it, there was a trail of oil, just like before. So the thing's operating basically just like it did before I tore it down, except it's worse, much worse. And I have no idea why. I was able to clean this up and reuse the head because that coking was an effect, it's not a cause. Okay. It was kind of hard to do. I had to use carburetor cleaner, that really nasty chemical. And what I did was I soaked it in that bucket face down for 2 days. And that's what it took to get it clean. The exhaust valve, I never could get it clean because the exhaust valve runs very hot and it will coke the oil. It'll turn it into almost a glass. And I couldn't remove it, and I ended up damaging the exhaust valve, so I had to replace it. The intake valve runs cold, and I was able to clean that one up. There's the piston. I didn't even bother with that. Look at that coking. It's really ugly.
What's that word you keep using?
Coke.
Like
C-O-K-E.
soda? I know it's not, but
It's crystallized oil.
okay.
It's really hard. Okay. So that leaves only one thing, the cylinder. Now, I called the factory and I called one of the service centers and told them that no, the rings are not upside down. And I described the effect and everything that I see here and so forth. And what I was told was that the cylinder is manufactured by a third party. And the surface treatment, the first of all, the nitriding, the hardness of the cylinder wall, that's a critical operation. It can be screwed up if you don't get the temperatures right. The crosshatch hone is very, very critical. The angle has to be right. It's got to be 45 degrees, plus or minus 5. That's done with a CNC hone. You can't do that by hand. Well, if you do it by hand and you screw it up, either the depth or the finish, which I'll show you in a minute, you're going to burn oil like crazy. So that's what I was told. And when they learned that I had the thing honed by Brad by hand, he just used a drill and a hone. While it looked okay, it was really very shallow. And I think he basically made it worse. I think the hone was the problem. So that's why I drew this here. If you had a magnifying glass and you were looking at the edge view of the hone pattern in an engine, you'll see it like that. You know, this is scratches, and they don't look exactly like that, but that's what you would see. Now, in the break-in process, the rings are going to wear those tips down. But before you start the engine, once you put the crosshatch hone in the cylinder, you then have to do a finishing hone, which they call a plateau hone. And what that means is you put a much finer stone so you end up with plateaus. And what's critical is the ratio of how much plateau you have versus how deep and how wide the grooves are. And I've seen videos and I've read a lot about it in the last couple of weeks. It's amazing how critical it is on a modern engine that's built with very tight tolerances like this. Yes.
Can you throw out the dimensions we're talking about here?
I don't remember, but you know it. What is it?
I was thinking something on the order of 10 thousandths of an inch. That's something you're going to make with a handheld hone.
Yeah. Yes.
So for those of us who don't work on engines or know engines really well, this hone pattern is a pattern inside the cylinder, correct? And so it's not smooth. It's got this kind of, its cross section looks like this, right?
You see it here? You see it in there?
You can't see it here.
No, notice that this is where the bottom of the piston is. Notice that in here, it's all gone.
It's not even there.
It's not even there. Yeah.
Dick, when I buy my UL motor and have the same problem, the answer would be to send the cylinder out to them. Yeah. To CNC that refit.
The real answer is just buy a new cylinder. It's $400. Yep.
Yeah, that was my point. So like, once it gets shaved down, there's no way you can add to it.
No.
Once it's down, it's gone.
Well, if you had the right machine, you could hone it all up smooth, and then repattern it. You could do that.
But you're eating into the nitride or the case art.
That's right.
On the surface, so
That's right.
you're gonna run out.
It's not advisable. So
And it's wider, even if it's just minute, right?
right.
You etched it even wider than
That's right.
its original.
So
You said something interesting. You might touch on that more. On the older, sloppy tractor engines that most of us are using, this isn't as critical. The perfection isn't as critical.
not as critical.
Which is why those engines don't produce fully efficient horsepower and all that.
And it's why typically mechanics will use a drill and a palm, do it by hand. It's not
Because it's smaller, tighter.
And it's also why burning a quart in 10 hours is acceptable. Yeah. Like yeah, it's just not that.
And in fact, you hear people bragging about, my four-cylinder Lycoming, I get 20 hours. I change the oil and it's down at 25 hours. I'm down a quart and a half. I don't burn any oil. That's why they've got a perfect hone. Okay, and it was broken in properly, so forth. So the bottom line is,
For like our wood engine, sometimes they do like an order more 10,000, something change the pistons on the rings to be, that's
Because of the nitride, that's not an option.
not an option here. Right.
So when I was talking to one of the repair centers, he says, he said, I think you're right. He said, I had one experience of 500 engines that are in use now in this country. He said, I encountered one engine with this problem. He said, I sold an engine to a guy like yours, to a guy in Florida. And after a couple of years, he calls me and said, hey, this thing's just going downhill. It's one cylinder. It's really bad. So I drove down to Florida and I did the top overhaul, just like you did, but it didn't change the cylinder. And it said 2 weeks later, he calls me back and says, it's even worse. So exactly what happened to me. So he says, what I did is I had to drive back down to Florida from Georgia. And so I just brought all the pieces. I changed everything all the way up to the case. I just changed everything, piston, cylinder, everything. He said, so I did that and that fixed it. So there was something wrong with that cylinder. And he says, I think you have figured it out. Yes.
Cylinder
Number two.
for them also?
No.
So you did the factory repair with a new cylinder piston. How's that compare to cost to a Lycoming replacing the cylinder?
How does it compare? You mean cost-wise? I didn't change the head, and I think all the parts cost me something like $1,100. Okay. Oh, a lot more. I don't know. I haven't done a Lycoming in a long time.
I was looking at prices.
The older engines with the straight valves, parallel valves, that's about $8,000 a cylinder. A cylinder. And then you go with the newer angled, that's $12,000 a cylinder.
Is that including labor or?
No, that's just the part.
That's just plastic.
That's the part.
320, one cylinder, front interior, it's like $1,200.
Okay, so what I did was I decided to replace everything, and I'm just about ready to run it. I've got it essentially all back together.
Got a new cylinder.
Yeah. In fact, there you can see that's the crosshatch home. You can see it very clearly, and you can also see it's not there. So here's a complete list of all the parts I reused. Cleaned up the head, the intake valve, no problem. There's the little cover that goes there, and the screws that hold it on. That's it. Everything else has changed. So that's my story, and I'm sticking to it. Yeah.
So I have two questions for you. One, what you believe that this originally was just a bad cylinder?
It was a bad home. Yeah.
From the factory.
Yep.
So nothing was installed properly. The rings were correct the first time. And then just because we actually just broke in the engine on our 182, and I'm 90% sure I understand it. But when you're talking about braking, what you're essentially saying is exactly what you showed there. Yeah. The first step is done via machine in the factory. The second step is done in the engine. The rings are honing down the crosshatching and fitting themselves.
They're getting
and not glazing like what you had.
In a modern engine, the really tight tolerances, not only will they do the hone with a CNC hone, but then they come back with a polishing stone that creates the plateaus.
Which is also why,
so the break-in is very quick.
That's what I was gonna say. Like in a modern car,
Right.
old cars it was a break-in period. In modern cars, you just start the car and drive.
That's
You're
right.
Essentially,
That's
You're
why.
factory broken in.
That's exactly right. Yes.
Based on what you now know, what would have happened had you continued to Oshkosh? Would it still have worked?
Well, that pattern of temperatures and horsepower and so forth didn't change a whit, all the way there and all the way back. So I could have made it up there and back, but that would have been a stupid decision. And I'm capable of those, but.
Right, but in theory, it wouldn't have gotten worse. It wouldn't have gotten better.
No, it did not. Yeah.
Using a lot of oil and having to land a lot.
Yeah, and this basically the motor's talking to you. It's sick. You know it is. You don't know what it is, and you don't know that it won't get worse. So you go home. Yes.
I'm curious about the details of the two automotive conversions you have in your RV12. The automotive conversion.
Well, I had two. I had a little Honda engine from Viking. It was a little 4-cylinder. It came out of a CR.
Fit. Honda Fit.
Honda Fit. Yeah.
Right. So they provided you like an engine and gearbox. Like
Right. Yeah, it's a small company. It's like 3 people, and they engineered a radiator system and a mounts and all that, and a gearbox and so forth. And all of those things are problematic. The reason is that it's a small engine because of weight. So you have to do a tiny little 4-cylinder engine. And in order to get horsepower, that means you gotta run it at very high RPM. So unlike in a car where only teenagers need the RPM, and only for a few seconds. But in the airplane app, I was running those little car engines at 6,000 RPM all day long. And while the core engine survived that most of the time, everything attached to it would vibrate and eventually crack and break, fall off, leak, disassemble itself. No, it was completely unreliable. The second engine was from a company called Aero Momentum, and it was a Suzuki conversion, and it was worse. So automotive conversions just don't work. What?
The Viking gearbox, is that a problem too?
It was early, but he figured that out. Actually, he's sold enough engines that he now has some good engineering that he buys and pays for. So I think his current gearbox is probably designed by a professional because it seems to have no trouble at all. Yeah.
I was going to throw in that engine now is used a lot in the Zenith
Yes.
community, and they seem to be past the teething problem.
Yep. It's 130 horsepower, just like mine is, but it weighs 150 pounds more than my engine. Yep.
This engine, can it be configured in a pusher configuration?
In a what?
Pusher.
Oh, yes, absolutely. In
Because
fact,
I noticed that there's a air intake or air filter.
you turn it
It's
around.
now backwards,
You
right?
can turn it around.
You can do that.
Yeah.
Look good on your
And
Look at look at
in fact, Scott Fish has a 6-cylinder version of this,
oh,
and it's a pusher.
okay.
Yeah. So,
And on that engine, this is the 6-cylinder version is what they're using on the Dark Arrow.
Yeah.
If the Dark Arrow ever flies.
if it ever flies. Yeah. So, anyway,
It taxis.
UL company in general, what's your feeling for their longevity? I heard the American rep, one of them bailed out, he was dissatisfied.
yeah, he was a U.S. distributor, and he had 2 repair stations working for him. But you had to go through him to buy an engine. 2 or 3 years ago, UL Power changed the discount to him and changed some rules, and just I don't know the details, but he found out about it at Oshkosh, and he said, "I'm out of here," and turned around and walked away and just quit. So that left the now we have the 2 repair centers, and both of those guys are factory trained. They spent 4 weeks over there getting factory trained, and now you buy the engine from either one of them.
So
But
if you buy another one of these, if you needed another one.
if I were buying another engine and I needed something in this horsepower range, and I'm concerned about weight, I wouldn't hesitate to buy another one, because like I said, there's 500 of them out there, and this is very, very rare. Only one other case in the U.S. that I was able to find. So I think the cylinder people had a bad day, and they, maybe their CNC hone broke down, and maybe they had to do a few by hand. I don't know. Yeah.
So you talked about like a lot of different types of engine options. Do you have any thoughts on the Rotex 912?
Well, the difference between the Rotex, which is it's a small engine. The 912 is only 1.2 liters. So it has to run at 5,000 RPM to get horsepower. And it's water cooled, and it has gearbox. But the difference is it's eminently reliable, has been demonstrated over the years, because the parent company is Bombardier. And that's a mega $billion company. And when they design an engine like that, like the recent ones that they've done, the IS models, they spend many years and hundreds of millions of dollars getting those things right. Whereas the little automotive conversion shops, this mom and pop, they got no money. They're often when you buy from somebody like that, they'll use your money to buy parts to build that guy's engine. And they'll hope that they'll sell another engine so they can buy the parts to build your engine. So it's
the difference between doing purpose-built for aviation and taking something and adapting it to a onesie twosie.
Exactly.
But the Rotex are reliable.
Very, very reliable. Yeah.
There's way more than 500 of those out there. There's thousands of them.
Oh, yeah. Many thousands. Okay, yes?
I got a question. Is the Rotex more expensive than?
Yes. Yes.
However, Rotex does have its problems. The latest on the RPs, the IS model, the radiators keep falling off.
I heard about that.
So they had a third bolt out for Rotex. Radiators, the RPs.
That's interesting. Anyway.
The unfortunate part about that is that's not the core engine or the gearbox.
Yeah.
Right.
It's some damn accessory hanging out the side and then adapted to the RV12.
Exactly.
It may be a man's aircraft adaptation where to put that radiator, and that's what's right.
And
Apparently, it's because vibration is currently attached to the engine.
Yeah.
And their fix is attached to the power.
Yeah.
Both radiators.
Yeah.
Humorous anecdote, just while we're on that subject. An engineer like Homing said once that their engines would last forever if they never bolted propellers in front of them. So, considering engines and those power plant adaptations, right? Torsional vibration is a killer.
Yeah.
And it is often overlooked and not fully considered when they design the crank, for example, and put in 3 mains instead of 5.
Right.
So there are oopses that happen.
Yep. And if it's a certified engine, it costs too much money to redesign.
Can't add 2 more bearings to it because it costs you $100 million.
That's right.
So,
When you're talking about the torsional rotation, is the practical fix for that just really good balancing, dynamic balancing?
It is proper engine. It's the proper. Yeah.
Most people who do these adaptations, they start talking about they don't understand what torsional resonance is, let alone how to fix it.
Right, you're talking on like a kind of home design adaptation, but for those of us that are putting like Homings and Continental.
Oh, like
Like you're
Home
saying-
Continental, you do what they say. You'll do
If the same, and get the thing, mass balanced and dynamically balanced down to 0.02 inches per second kind of thing. That's the proper fix. Do not just bolt up a prop and go, yep, here you go. Right.
Did that come in like with the de facto with your with the Airstream?
All those dynamics change. I mean, even doing the balancing on the ground with the nose pointed at a different angle with the relative winds will change how you.
So you can minimize it. You can't get away from it.
You can't ever get to 0.
Yeah.
Okay, that's all I have.
That was great, thank you.
Thank you.